This is a lab 2 report of the line of charge presented by Xinyu Gong. In this report, I'm gonna go through the introduction of this lab, the fundamental theorem, experimental process, my glow script analysis, and the final evaluation about the result and the what if and why question. This lab performed as a continuation to lab 1, however we now treat the charge tape as a charge line instead of a charge particle. We'll assume all charges are distributed evenly in the line. This is because we try to analyze the interactions between the two charge tapes in a more realistic manner. The fundamental theorems applied in this lab are the charged objects attract neutral objects, that is the polarization of the neutral tape. And superposition of electric fields, the formula to compute electric fields and electrical force, and the momentum conservation principle. For this experiment, I go through the same procedure as lab 1, but now assume the charges are distributed in a line rather than as a single particle. And the important measurements I recorded are listed below. The length of the charge tape are approximately 20 centimeters with a mass of 0.2 kilograms per tape. And the separation between the tapes when the upper tape flows is about 0.011 meter. In my analysis, I assume each U-tape has the same net charge evenly distributed along the lines, and secondly, I ignore the air resistance of the moving tape since it is moving slowly. So there's only two forces applied on the top tape, that is the electrical force and the gravitational force. And here is a simplified free body diagram of this experiment. I divided the top and bottom tape into equal lengths of line segments, and each segment is presented as a concentrated charge of same magnitude. And each charge on the bottom tape is experienced by forces from all charges on the top tape, with a net force presented by the yellow arrow here. This is my code in glow script. You can check it here using the link here. And in this glow script analysis, I've imported the sample code and added some constants with my previously observed values and updated the functions of E-field and tape representation using the fundamental theorems I introduced above in the last page. Here's the result of my glow script analysis. The red dots here are the concentrated charge on line segments of the top tape, and the blue dots here are the concentrated charge on the line segments of the bottom tape. And on each of the red dots, the green arrow represents the net force experienced by that particular concentrated charge, and the white arrow is the net electrical force experienced by all of the red dots, red charges on the top tape. And the yellow arrow represents the gravitational force experienced by the top charge tape. And we can see here that when we inputted an estimated charge that is 1.49 times 10 to the power of negative 8, the two forces, the electrical force and the gravitational force, now reaches equilibrium. For the what if and why question, we can see that our result for the value of charge on the top tape, when we see it as a point charge, is 5.13 times 10 to the power of negative 9 coulomb. But when we change our assumption to a line charge, that value becomes 1.49 times 10 to the power of negative 8 coulomb. And there's a difference between the two estimated results because we try to break the tape into smaller pieces in lab 2 and try to find the summation of all forces on each piece of tape instead of ignoring the length of the tape in the first lab. So the second result will be more accurate as it is closer to the model of the charge tape in reality. And in reality, the excess charge will not concentrate on a single point, but are spread out throughout the whole tape. Thank you.